Hello dear students, I am Surendra Sir, Master Teacher of Mathematics in Vedantu. In this session I am discussing HWT Test-9 most incorrect questions done by the students. This test is based on complex number and locus. So before we start solving the questions, I will like to give you few important results, ideas before we start solving these questions. So the very first thing is, you have seen many times you are given in the question that Z is a purely real, purely imaginary. So to understand that how we can deal with such questions, the one idea is that Z plus Z conjugate is equal to 2 times real part of Z. As you know, Z being x plus iota y, and Z bar means just minus sign here. So Z plus Z bar will be 2 times x, so 2 times real Z. So if Z is real, Z is purely imaginary, then this will be 0. So Z bar will be equal to minus Z. That can be one important condition for Z being purely imaginary to solve your question. Although you can do directly also by equating real part x equal to 0, by comparing real part, imaginary part, and making real part 0 for this thing. Similarly, Z minus Z bar will be 2 times iota imaginary part of Z. So if Z is a purely real, then Z will become equal to Z bar. Again, this is the condition can be used to solve those questions where you are given Z is a purely real. Okay. Now second thing, mod Z. Mod Z for any number, let's say A represented by complex number Z on Argand plane, then mod Z means its distance from origin. Mod Z means distance of A from origin is called the mod, which means if we denote the locus like mod Z equal to R, mod Z equal to R, mod Z less than R, mod Z greater than R. In this case, what will happen? Suppose this is my origin O and I am saying mod Z equal to R. Mod Z equal to R means all the complex numbers which are at distance R from origin. So you know this will be a circle, because circle having every point on the circle having same distance from its center. So in this case, center will be origin, radius will be R. So this will be the locus for mod Z equal to R. Now if you are looking for mod Z less than R, that means it will be portion lying inside this circle. Okay, portion lying inside this circle. Similarly, if mod Z greater than R, mod Z is greater than R, then it will be the portion outside the circle. Okay, so these are three things. Now similarly, if we are looking for mod Z minus Z naught equal to R, less than R, greater than R, it will be same thing. It is just your circle will be having center at Z naught. If it is equal to R, then it will be circle, that means circumference. If it is less than R, then it will be inside region of the circle. If it is greater than R, then it will be outside region of the circle. In some cases, it can be less than or equal to, then you know it can be circle, circumference and the inside region. Similarly for greater than or equal to R. Okay, so these are two things. Now coming to third thing, that is argument. So when we say argument, dear student, you must know for any complex number Z, if you join it with origin O, then the angle with positive x-axis, this angle theta is called the argument for any complex number Z on Argand plane. Principal value. Before principal value, let me tell you, the theta can have infinitely many values, because the same angle theta can be said to be 2 pi plus theta, can be called as 4 pi plus theta, and so on and so on. You can keep in adding 2 pi to it and you will be getting the same argument. That means argument can have multiple values. But principal value, if it is mentioned in your exam, in your paper, then you must know its value starts from minus pi going till pi. I think it is open bracket at minus pi. Yeah, it is open bracket at minus pi, close bracket at pi. So whatever infinite values of an argument you may have, those values, and it will be just one value that lies in the interval, will be called as principal value of that argument. Okay, now coming to argument of Z minus Z naught. Suppose your Argand plane is given like this, and somehow suppose Z naught is some point here and Z is some point here. Now we are looking for argument of z minus z naught. How to find that? Please understand this. In this case, we have to start from z naught and going towards z. So it is like final to initial, final minus initial. Actually it is initial to final, but when we write this in our vector, we call this as final minus initial. As you know, in the displacement, final position minus initial position. So that will be your displacement vector, you can say. So this is how your vector on Argand plane, or this OZ I denoted here when we were talking about argument of Z. We can talk about this here also. Now do one thing, copy this thing and paste it so that your Z0 point now coincides with origin. In this case, your Z will be coming at Z minus Z0. Z will be coming at Z0. In that case, this angle, as we know the definition, will be the argument. So if we want this directly on this Z0 Z, in that case it should be join a line or draw a line passing through Z0, which is parallel to x-axis. This angle theta will be the argument of Z minus Z0. Okay, so always this way you can think of argument of Z minus Z0. Now next thing, what is the difference between argument of Z minus Z1 minus Z2 and argument of Z2 minus Z1? I think what I told you here, it becomes very simple. So if it is Z1 and this is Z2, okay, if you are looking for Z2 minus Z1, your arrow will go this way. You draw line this way, so this will be the theta for Z2 minus Z1. But if you are looking for Z1 minus Z2, then let me draw different diagram so that there is no confusion. In this case, arrow will be going like this, and Z2 is this, and Z1 is this. Okay, now this is the starting points. We will draw a line parallel to x-axis. So this will be the argument. And you can compare with this. If this was theta, I think this will become pi plus theta. I will tell you another way of doing the same thing, but graphically, geometrically, I hope you will understand that argument of Z1 minus Z2 will be pi plus theta. Now this thing will come from the property I will show you just now. The property is that argument of Z1 into Z2 is actually equal to argument of Z1 plus argument of Z2. If it is divided by, then it will be argument of Z1 minus argument of Z2. If power n is there, then you can take n outside and argument of Z. The both sides are equal for certain value of argument, because we know argument has infinitely many possible values. So you can add 2 pi or 2n pi on any side to make other side equal to this thing. So this equality will definitely hold for one of the value of argument here and one of the value of argument here, but the difference of 2 pi, if it is there, it is okay, because we know argument has infinitely many values, all differing by multiple of 2 pi. Okay, now I was talking about this thing. So dear students, you can see, if you are looking for argument of Z2 minus Z1, I can write this as argument of minus 1 plus argument of Z1 minus Z2. Okay, now minus 1 being on negative x-axis, so its argument will be pi, and this is theta. So you can see this is becoming equal to pi plus theta, which we saw geometrically also through this diagram. Now next thing, and that is few forms of complex number. One is polar form. We know that z is equal to x plus iota y, where x is the real part and y is the imaginary part, but we can also write it is in polar form, r into cos theta plus iota sin theta, and same thing can be written in the form of Euler form, where z is equal to r into e power iota theta. So this cos plus iota sin, cis, we call this in shortcut, you can say cis, is actually replaced by e power iota theta. Okay, here r is actually the mod of z and theta is argument of this z. Same thing here also. You can see e power iota theta is equal to cos plus iota sine. So if you take mod of this thing, it will be equal to cos square theta plus sine square theta under root. So it will be 1. So we have written Euler form, polar form, so that the modulus part will be here, and this complex number will be a complex number of modulus 1, you can say. So if you multiply them, the modulus will not change. So this is actually giving you the information about modulus, and this is giving you information about argument. It is always having modulus equal to 1. This is having argument, because r being positive real number, argument always equal to 0. So we have actually splitted the information in two parts. Argument, if you want to know, then contact this part or e power iota theta part, and if you want to know the modulus, then contact this r. So this is how polar form, Euler form are giving you directly the values of Euler form, directly the values of modulus and argument. One more thing, these forms gives you very obvious properties, direct proof of properties of modulus and argument. If you multiply such two complex number, you can see their modulus will get multiplied, their argument will get added. If you divide them, modulus will be divided, argument will be subtracted. So this form is very important in that sense also. Okay, now let's start doing few questions. So the very first question is, Z lies on the line segment Z1 and Z2, then which of the following is correct? I think I have just told you. Okay, so between these two, so this is Z minus Z1. So what they are saying, first of all, they are saying Z1 and Z2, and Z is lying in between. Okay, so Z minus Z1, if I talk about Z minus Z1, so if I draw this arrow, so argument of Z minus Z1 will be this theta, whereas if you are looking for argument of Z minus Z2, Z minus Z2 means it will be like this. So your angle of this would be pi plus theta. So that seems wrong. For Z minus Z1 will be theta. For Z minus Z2, for Z minus Z2, the angle will be pi plus theta. You can do it by other property also. Similarly, here Z minus Z1, I think Z minus Z1 is same theta, and Z1 minus Z2, Z1 minus Z2 will be again, because this time we will be drawing, just 1 minute, yeah, same angle actually, so pi plus theta. So here also this is not correct. Z minus Z1 is theta, Z1 minus Z2, because this is the final point, this is the initial point. So if you join these two and you then you measure the angle from positive x direction, so this angle will be the argument of Z1 minus Z2. So this is also wrong. Now coming to the next thing, Z minus Z1 and Z minus Z2. I think we have seen this thing, the difference of these two will be pi. So this is also not correct. So only correct option is this, for this is none. None of these are correct, so D is the answer of this question. Okay, I hope you have understood what I have said. I will repeat once more. This Z is lying in between Z1 and Z2. So in order to find the argument of Z minus Z1, we need to draw arrow like this, and that is my initial point. Drawing x-axis from this will be the argument of Z minus Z1. But if it is Z minus Z2, your arrow will be going like this. Z2 being initial point, this will be positive x-axis. So from positive x-axis, the angle will be pi plus theta. So this is the angle for this Z minus Z2, pi plus theta, and same for, I think, this also. If it is theta, if it is theta. So A, B are wrong, C is also wrong, D is the only correct answer of this question. Coming to the next question. Z1, Z2 are complex numbers such that Z1 bar plus iota Z2 bar is equal to 0, and we are also given one more relation. We have to find argument of Z1. So dear students, what you can do, one equation we get from it here. So we will be getting argument of Z1 plus argument of Z2, and that will be equal to pi. For this we can write Z1 bar is equal to minus iota Z2 bar, and if I take conjugate on both sides, okay, so this will be Z1, on the other side conjugate of minus iota will be iota, conjugate of Z2 will be just Z2, and then if I take the argument on both sides, so argument of Z1 will be equal to argument of iota argument of iota, that is pi by 2, plus argument of z2. Okay, now we have to eliminate argument of z2 to get answer for argument of z1. Okay, so if you add these two on both sides, you can see this argument of z2 and argument of z2 will be cancelled, and this side we will be getting 2 times argument of z1. On the right hand side it will be 3 pi by 2. So this argument of z1 will be 3 pi by 4. So answer of this should be D. So that is one of the method. You could have done this question another way also. Let me tell you. We found z1 is equal to iota z2. So you can put z1 is equal to iota z2 here, or because we are looking for argument of z1, so we can put z2 is equal to z1 upon iota here also. It will give you same thing after one step. If you put z2 here, we will be getting argument of, I think, z1 square upon iota is equal to pi. Using that property, argument of z1 square minus argument of iota, which is pi by 2, is equal to pi. It will go that side, then divide by 2, we get the same thing. So argument of z1 will be 3 pi by 2 divided by 2. So 3 pi by 4 is the answer of this question. Okay, now coming to the next question. Z is equal to x plus iota y satisfies this equation, then z lies on. Now one method for this is write it in terms of x plus iota y as they have given. Okay, so that will be the first method. Please see. So left hand side is x square minus y square. You just have to whole square it. So x square plus iota y whole square. So x square minus y square plus iota into 2xy. On the right hand side, iota is outside, and mod z we know it is under root of x square plus y square, and because whole square is also there, so this will become x square plus y square. Now two things, one is x square minus y square, that is equal to 0, and second thing is 2xy is equal to x square plus y square. Now from this thing alone we can say it becomes x minus y whole square is equal to 0. So we get x is equal to y, and that is actually coming from this also. Although this have two things, x is equal to y or x is equal to minus y, but in order to solve both of them, I think we will go with x equal to y. So answer will be B of this question. Okay, now second method, as I was talking about, if you take your complex number in polar form or Euler form actually, so z, if I take z as r into e power iota theta, z square will be equal to r square into e power iota 2 theta, and that will be equal to iota into r square. R square gets cancelled. Iota has argument equal to pi by 2, or you can say 5 pi by 2. So you can say this 2 theta will be equal to pi by 2, or you can say 5 pi by 2 also. In fact, iota have multiple values, but here when we are dividing it by 2, these two will give you pi by 4 or 5 pi by 4. But the interesting thing here is that whether you take pi by 4, it is lying along this line, and 5 pi by 4 you take, it lies along this line. So both are actually y is equal to x. So answer of this question will be B only from both the methods you have seen. Okay, now coming to the next question. The area in square units of the region. Now z minus 1 mod less than or equal to 1. That means it should be a circle, okay, whose center will be at 1, 0. Because center is 1, 1 means 1 at x-axis, so 1, 0 on xy plane you can say. Also they are given real part of z is greater than 1. If this is x coordinate being 1 here, so this will be the line x is equal to 1. So real part means x coordinate greater than or equal to 1, it should be lying on the right side of this line. It should be lying on the right side of this line. And then imaginary part is greater than or equal to 0, which means it will be lying above this x-axis. See, this at x-axis 1, 0 will lie. On this line x is equal to 1, right side, this real part will be greater than or equal to 1, and imaginary part greater than or equal to 0 will be this region. Okay, so if I combine all of them, I think we are getting this region, that is 1/4 of a circle whose radius is 1. whose radius is 1. So 1/4 of a circle means pi by 4 should be the answer of this question. Okay, now moving to the next question. The locus of z such that real part of this is equal to 1. Now we can do it in two ways. Listen carefully. I told you in the beginning that one method could be that we write z minus 1 upon 2z plus iota and its conjugate. Its conjugate would be z bar minus 1 upon 2z bar minus iota. Its sum should be equal to 2 because it is equal to 2 times the real part. So that is one method. I will come to that calculation later on, but let me do this question by some other method, by taking z is equal to x plus iota y. So for this complex number, if I write z as x plus iota y, your numerator would be x plus iota y minus 1 and in the denominator it will be 2x plus 2 iota y plus iota. Okay, now we are looking for its real parts. So it will be better we write this in the form of x plus iota y. For that we will be multiplying and dividing by the conjugate of the numerator. I think that's a very standard technique. So 2x plus iota into 2y plus 1 is the number in the denominator. If we multiply it by its conjugate, that means it will be 2x minus iota into 2y plus 1. In the numerator, we will be writing x minus 1 plus iota y and this will be multiplied by this thing, that is 2x minus iota 2y plus 1. Okay, now what is 1? The real part of this thing, and real part will come from where? When real number multiplied with real number, so it will be 2x square minus 2x, and this x minus 1 bracket multiplied with 2x, so 2x square minus 2x, and also when iota y multiplied with this thing, so minus minus plus, because iota into minus iota will be plus 1, so it becomes 2y square plus y, 2y square plus y, and that will be equal to, sorry, not equal to, let me write this way, upon this thing is actually multiplication of one complex number on its own conjugate. When it happens, we know z into z bar becomes equal to mod z square. Also you can see directly it is a plus b into a minus b form, so this becomes 2x whole square, so that is 4x square, and minus minus plus, it will be 2y plus 1 whole square, and that is equal to 1 because this is the real part we are looking for. So if we take that side, okay, so we will be getting 2x square plus 2y square minus 2x plus y, 2x square plus 2y square minus 2x plus y, and that will be equal to, on the other side, 4x square plus 4y square plus 4y plus 1. 4x square from here, 4y square plus 4y plus 1. Now if you simplify it, you can see on one of the side, if you bring everything, you will be getting coefficient of x square being 2, coefficient of y square being 2, and there is no xy term, which means it should represent a circle. We saw in our previous video that general equation of circle is like this, whose coefficient of x square and coefficient of y square should be equal. There should not be any xy term. So here we will be getting this locus being locus of a circle. So A. Now this method I was talking about, in this case also we will be doing similar thing. We will be taking LCM. Okay, so let me do it on the next slide. So what I was saying, z minus 1 upon 2z plus iota plus z bar minus 1 upon 2z minus iota, and that should be equal to 2 because complex number plus its conjugate becomes equal to 2 times its real part, and we are given real part being 1, so it will be 2. Now take LCM, so it will become z minus 1 into this thing, so 2 into z bar minus iota into z plus, not plus, actually minus 2z bar and minus minus plus iota plus here also 2z z bar and minus 2z plus iota into z bar and minus 1 whole divided by, if you multiply these two, it is 2z z bar minus iota, if I take common, So it will be 2z minus 2z bar plus 1, and that is equal to 2. Okay, now let us see if something is getting cancelled out. I think this iota and minus iota is getting cancelled. 2z, and here it is minus iota z. Okay, 2 iota z bar, and here it is. Okay, so let us write this way: 4z into z bar in the numerator. Okay, and if I write these two things together, minus 2 times z plus z bar, it will be. Similarly, here minus iota and it is plus iota. So if I take plus iota, it will become z bar minus z. Okay, all is done from the denominator, and equal to, this will become 2 into 2, 4z into z bar. Okay, here minus 2 iota, and this will be 2z minus 2z bar plus 2. So this is what we are getting. Now try to write all of the things on one side. Maybe I will bring this here. Have I done something wrong? Because yeah, actually this should have been 4 here. This should have been 4 here. So this will be 8 here. Okay, so if you bring it here, we will be getting 4z into z bar. Okay, and this thing, if you bring it here, so this will also be with minus sign iota, but this is z minus z bar minus z, so this side it will be same thing as this. So finally what it is becoming is actually minus 3 iota and z minus z bar, because minus 4 iota, and this will be plus iota when you bring it this side. Okay, and minus 2 into z plus z bar, minus 2 equal to 0. So now z into z bar, we know it is equal to x square plus y square, and this will be just iota y into 2, this will be 2x. So here also you can see from comparison it becomes equation of circle. Okay, in this question probably you will feel this calculation is more, but that is okay, and the purpose was to show you how this way question can be done. So method 1 is better for this question, but this can be better in some other questions, so please keep this also in our mind. Okay, so coming to the next question, very simple question bachcho. It will be purely real. So if it is purely real, means its imaginary part should be 0, or we can say 3 plus 2 iota sine theta upon 1 minus 2 iota sine theta should be equal to its conjugate. So it will be 3 minus 2 iota sine theta upon 1 plus 2 iota sine theta. Because if they are purely real, number should be equal to its own conjugate. So if you do the cross multiplication, we will be getting 3 into 1 3, and this multiplied with this will give you minus 4 sine square theta. Okay, and if you and this thing, other terms actually. Other terms would be, when you multiply 3 with this, so it will be 6 iota sine theta, and when this multiplied with this will give you 2 iota sine theta. Now, equating this will give you 3 minus 4 sine square theta. Okay, and it will give you minus 6 iota sine theta minus 2 iota sine theta. So this 4 sine square theta and 3 will get cancelled. So you can see everything is getting added. So we are getting 6 plus 2, 8 into 2, 16 iota sine theta is equal to 0. Sine theta becoming 0 means you should be getting this to be n pi. Then only this sine theta becomes equal to 0. Dear students, in this question, some people may directly observe that sine theta being 0 will give you 3. Okay, so that can be one of the answer. So some of you may say this can be correct answer directly. I will go with you, but I will just give you one precautionary word, that check whether A, B, A, C, D, A, C, because D will not be the answer if B is already satisfying it. So you just check whether some of the value is satisfying it or not satisfying it. So maybe there can be some catch which you cannot see directly. So just to make sure that you are not making any error, just check these values, otherwise go with this proper method. So then definitely there is no chance of getting any error. question. I think similar question. In this case, they are saying purely imaginary. Okay, let me see if it's the same question. 3 plus 2 iota and 1 minus 2 iota. Okay. So in this case, purely imaginary means it should be 3 plus 2 iota sine theta upon 1 minus 2 iota sine theta added with its own conjugate will give it to 0. 3 minus 2 iota sine theta in numerator, 1 plus 2 iota sine theta in the denominator when you are taking the conjugate. Now take the LCM and this will go that side, you can ignore it. So only the thing that you will be getting in the numerator. So 3 minus 4 sine square theta. Then iota terms would be 6 iota sine theta. Okay. Also, you may not write this thing because these two are conjugate of each other. So if you're adding them, it has to be a real number. So what I'm saying, even if you calculate for imaginary parts like 3 into 2 iota 6, 3 into 2 6 iota sine theta and plus 2 iota sine theta. Okay, and multiplying this will give you 3 minus 4 sine square theta. Okay, and you can check. When you multiply 1 with minus 2 iota sine theta, you will be getting minus sign outside, 2 iota sine theta and 6 iota sine theta. So there is no need for, writing these things because they have to be cancelled. So from this we are getting 3 minus 4 sine square theta is equal to 0. So sine square theta will be equal to 3 upon 4. And that is corresponding to 60 degree minus 60 degree, those kind of angles. So if we choose from this thing, I think it will be minus pi by 2 to pi, we have to see. So I think it will be minus pi by 3, minus 60 degree. So minus pi by 3 is not there. Okay, it is not there. So what is the problem here? Is purely imaginary. Okay, it is plus minus actually. So it can be this also, it can be this also. Okay, so in this range, I think pi by 3 will work and then 2 pi by 3 will work. 2 pi by 3 will work. So answer should be D of this question because both 60 minus 60, 120, they will work. So this answer will be D. In fact, what I was talking about here that these two will cancel. Actually, that was applicable in the calculation here also. Please understand. Because I am equating a number with its own conjugate. Okay. So it is like Z is equal to Z bar. So it should be just X plus iota Y is equal to X minus iota Y. So this real part has to be cancelled and you can see the real part was actually cancelling here. So we need only take care of the imaginary part. So whenever you are doing this calculation, the real part are always bound to cancel. Only imaginary part will be there and that 2 times y equal to 0 it will become. So that is what we got from here also. So that was giving you the answer for this question where real was given for this complex number. I think done. Yeah. So that is all for this session. Thank you so much. I'll come in next session very soon. Thank you. Bye.